This is Harshit and we will be studying some course on digital electronics. First of all, let us start with combinational circuit. A combinational circuit is nothing but just a combination of gates. By gates we understand that these are the normal gates that we use, just like NAND gate, AND gate, NOR gate, XOR and XNOR. These are the basic gates which we will study about combination of gates. So the next thing about the combinational circuit is it doesn't have memory. सर्किट वो सर्किट है जिसमें गेट्स को हम कंबाइन करके एक सर्किट डिजाइन करते हैं जिसको यूज करके एक कोई भी प्रैक्टिकल प्रॉब्लम को सॉल्व करते हैं. ऑल्सो द कॉम्बिनेशनल सर्किट डजंट हैव मेमोरी, मतलब जो इनपुट हमने दिया वही आउटपुट उस समय मिलेगा. इट डजंट डिपेंड्स ऑन द प्रीवियस आउटपुट और प्रीवियस इनपुट. सो दिस इज ऑल अबाउट कॉम्बिनेशनल सर्किट. द अदर सर्किट्स दैट आर सीक्वेंशियल सर्किट्स. These two topics are mainly very important for the point of view of GATE and IES, engineering services. So first of all we will study about first combinational circuit, that is full adder. So now types of combinational circuit. So we have in combinational circuits we have adder that add 2 or 3 bits. We have subtractor and multiplexer. Multiplexer is a kind of combinational circuits that converts one input into many that converts multiple inputs into a one output circuit. And the another one is demultiplexer, also known as demux. This is known as mux and this is known as demux. These are special categories known as encoder and decoder, which we will study about later. So first let us consider about adder. सबसे पहले we will consider half adder. A half adder is a device which simply adds 2 bits. मतलब सिर्फ 2 बिट का एडिशन होगा यहाँ पे. अगर अपने पास इस तरह से बिट्स दे रखी है, अगर एक A इनपुट ये है और एक B इनपुट ये है, अगर 0 और 0 दे रखा है तो it will add around and it will give 0 only. अगर 0 और 1 दे रखा है as a input, so it will add around and give 1, and it is when 0 or 1 और 0 दे रखा है तो it will give 1, और जब 1 और 1 दे रखा है तो it will generate a carry. So we will write separately about carry and the output will be 0 only. So these bits are sum bits and these bits are carry bits. While we are adding 0 and 0, 0 and 1 and 1 and 0, we get no carry, so it is 0. Now for this kind of circuit we need to design a circuit using AND gates and NAND gates. So this is the table what we have to design. So for sum and for carry we have to design a separate circuit. Let us make a truth table for that, and from that we will make a K-map. Now first of all for sum, and this would be for carry. So in K maps where we have 1, जहाँ जहाँ 1 होते हैं उन ones को हम K map में substitute कर देते हैं. So we have 1 for 0 and 1. This is 0, this is 1, this is 2 and this is 3. ये सब this way will deal in a separate section known as K map. So let us only first focus on how the logic is built rather than how the K map is constructed. One here, and in the carry 1 will be here. This one. Okay. So from this we have to make equations for sum. The sum will be, this is A and this is B bar, AB bar, this is A bar and this is B, A bar B, and this is simply carry is AB. Also we know that this operation A bar B and plus AB bar is carried out by XOR gate, and this operation is carried out by AND gate. So we have find out that how a half adder can be constructed simply by using XOR gate and AND gate. So we can see so now we will design half subtractor. Half subtractor मतलब simply दो bits का difference और borrow. अगर difference आएगा तो this will give, अगर borrow आएगा तो this part will give. We have to design this circuit. We will now study how to design this circuit. Okay. So let us take difference of these bits. 0 minus 0 is 0 and no borrow. 0 minus 1. Obviously lower bit cannot be subtracted from higher bit cannot be higher bit cannot be subtracted from lower bit. So 0 minus 1 as such is not possible, so we have to take a borrow, and taking borrow it becomes 1 0. In binary digits the borrow turns it into 1 0. So when we subtract 1 from it, it will get 1. So difference is 1 and borrow is also 1. Now while subtracting x minus y, this is 1 minus 0, we will get 1 still and 0 borrow. And by subtracting x minus y, 1 minus 1, it is 0, and this is also 0. Okay. So now we will use this truth table to construct K maps. Okay. From these K maps we will derive equations, and then from these equations we'll finally arrive at this logic circuits. These are the basics for studying further complex problems that are asked in IES and GATE. So now this is x and y difference. We have to construct the difference K map. Difference K map is like this. This is 0, this is 1, this is 1, and this is 0. So for this equation will be, also this is, let us first fill borrow also. For borrow it is 0, 1, 0 and 0. Okay. So now we have constructed K map. We will construct now equations for that. So constructing equations, we can see that here it is this and it is this. This is x y bar and this is x bar y. This is x bar y. So for difference it is x bar y plus x y bar as seen from the K maps, and for borrow it is x bar y. Okay, so for these equations we have constructed this diagram. This is a XOR gate. इस XOR गेट की मदद से हम ये इक्वेशंस बना सकते हैं. इसका आउटपुट इस तरह से आता है, x बार y और y बार x, एंड दिस इज अ बोरो गेट. बोरो गेट में क्या है, x बार और y इनपुट देना है इसको, तो ये दोनों को मल्टीप्लाई करके हमारे पास x बार y आ जाएगा. अब x बार लेने के लिए हम इस x इनपुट के आगे एक नॉट गेट लगाते हैं, दैट इज डिनोटेड बाय अ डॉट, x बार y. So this is all about half subtractor. Now we will more study about full subtractor and full adder in the next video. Now we will study about full adder. Full adder क्या करता है? Full adder 3 bits को add करता है. It will add 3 bits one by one. So we have taken 3 bits like x, y and z. अगर 0 0 0 add करेंगे तो the sum obviously will be 0 and carry would be 0. 0 0 1 add करेंगे तो sum आएगा 1 and carry would be 0. Similarly, if we will add 0 1 1, so we will get a carry that is 1, and as taught in the previous adder, like it is, अगर एक 1 और 1 को add करेंगे तो this will turn out to be 0 and there would be a carry on the another bit known as 1, called as 1. Okay, so this would be the output and this would be the carry. So it is easily understood that what would be the sum output and what would be the carry output. So जब 0 1 1 को ऐड करेंगे तो हमारे पास कैरी आएगी और सम में 0 बिट आएगा. इसके बाद सिमिलरली वही 1 0 0 को अगर ऐड करेंगे so we will get sum 1 and carry 0. Now 1 0 1 we will add same like this, 1 1 we will get some bit as 0 and the another bit will be 1, the carry bit. Okay, so similarly in the next one, the 1 1 0, we will get some bit to be 0 and carry bit to be 1. Now this is a case known as 1 1 1. Okay, so it is like 1 1 1. This 1 and 1 would add up to 1 0. Okay, अब इस 1 0 में अगर एक और 1 ऐड करें तो this would be 1 1 1 as carry and this 1 would be the sum bit. So this is what I have written here. This is sum and this is carry. This table is easily understood. Now we will move up to the truth table, and from this truth table we will draw a K-map to design logic circuits. किसी भी to design a logic circuit we have simply 3 steps. Draw the truth table, draw a K-map, make out the equations, and from these equations we will draw the circuit, or we can say the logic circuit. So this is 1 here, 1 here, 1 here, and this we will substitute here in K-map. We already know the technique of K-map that we have studied in the previous lectures. So this would be 1 and 1 here. This is like this. This is 0. This is 1. This is 2. This is 3. This is 2. 4, 5, 6 and 7. From this we can easily make out this. This is 0, this is 1. From 1 here it is in the 1. This is like this. 0, 1, 2, 3, 4, 5, 6, 7. फर्स्ट वाले बॉक्स में 1 आ रहा है, उसके बाद सेकंड वाले बॉक्स में 1 आ रहा है, इसके बाद फोर्थ वाले बॉक्स में 1 आ रहा है, इसके बाद सेवंथ वाले बॉक्स में 1 आ रहा है. अब जब इन 1 से हम के मैप बनाएंगे, इनको ग्रुप करेंगे, तो वी विल गेट दीज इक्वेशंस. दिस इज x y bar z bar, this is x y bar z bar, this is x bar y bar z, this is x bar y bar z, this is x y z, this is x y z, and this is x y z bar. This is the normal method to sum these. एक शॉर्टकट है, जब भी इस फॉर्म में अगर हमें वंस मिले किसी भी के मैप में, इस फॉर्म में, इन द फॉर्म ऑफ साइन वेव और इन द फॉर्म ऑफ कर्व, वी कैन डायरेक्टली राइट दिस इज एज x XOR y XOR z. इसको हम, this equation can be realized using a 3 input XOR gate. 3 input XOR gate. Okay, So now we have to make for carry. Carry में हमने देखा कि 3 में बना रहा है. Let us number this. 1, 2, 3, 4, 5, 6 and 7. So this is, अब देखेंगे हम 4 में we are getting 1. This is okay. We are getting 1 in 3. We are getting 1 in 5. We are getting 1 in 6 and 1 in 7. So these one we have to group like these, like this, like this. So we already know about the grouping methods when we have studied in K-maps. So this is how we can group this. And now from these groupings, we can make the carry equations like this. This group will turn out to be, we can say common is Z, and this is X. So this group will turn out to be X, Y, Z. This group will turn out to be X and Z. Okay. So अब हम we will study about how to design a carry circuit. Carry circuit, it is simple. We will first substitute ones. 1 is in 3, 5, 6 and 7. 3, 5, 6 and 7. Now after substituting this, we need to group these ones. So we are grouping these ones like this, this, this and this. Okay. So after this, we need to make groups and we need to write equations. So this grouping this one and this one we will get YZ. We have written this YZ. This one and this one we will get XY and this XY. This one and this one we will get XZ. XZ. Okay. So this is normally the equation of carry. Now sometimes it is asked in exams like ESE in the canonical form, in which all the implicants should be present. So canonical form of this equation is this. Here in all terms all the implicants are present. Implicants are variables like X, Y and Z. So this are present in this X, Y and Z. These are present in all terms.